Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 26 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2033. Minimum operations to make a Uni-Value Grid. So let's read the problem statement first. You are given a 2D integer grid of size m into n and an integer x. In one operation, you can add x to or subtract x from any element in the grid. A uni-value grid is a grid where all the elements of it are equal. We have to return the minimum number of operations to make the grid uni-value. If it is not possible, then we have to return -1. Okay, so let's see example number 1. So this is grid given to us and x is equal to 2. Okay, so from any element we can subtract 2 from it or we can add 2 to it so that all the values in our grid becomes equal, and we have to do this in minimum number of operations. Okay, so now let's suppose I want to make all the elements in my grid equal to 6. Okay, so if I want to make all the numbers equal to 6, so here I have to add 2 times, right? Plus 2 and plus 2. Okay, and here also I have to add 2 one time. Here I have to subtract 2 one time. Okay, so here I am adding 2 times, right? So here 2 plus 2 4 plus 4 plus 2 6. Here 4 plus 2 6, and here 8 minus 2 6. Okay, so here see how many operations I am doing. 1 2 3 4. Okay, 4. All right, now here let's suppose if I want to make all the numbers equal to 8, then here I have to add 2 3 times. Okay, 1 2 3 4. Okay, and here also I have to add 2 times. Okay, 4 5 6 7 8, and here I have to add 2 times, one time more. Okay, so in total, if you see, if I want to make all the numbers equal to 8, so here I am adding 2, 1 2 3 4. Okay, so total 3 times I am adding 2 here. Okay, 1 2 and 3, and here I am adding 2 times, 4 5 6. Okay, 6 operations I am doing. Okay, if I want to make all the numbers equal to 8. Okay, but this is best na. Okay, this is best if I want to make all the numbers equal to 6. Same way, if I want to make all the numbers equal to 4, so then also here I have to add 2 one time. Here I have to subtract 2 one time, and here I have to subtract 2 times. Okay, then also 4. Okay, so here if you see, we can make every element equal to 4 by doing the following. Add x to 2 once. Okay, here 2 once, and then here we have to subtract 2 one time. Okay, from 6 once, and here I have to subtract x from 8 to twice. Okay, so in total 4. Okay, and same way. Okay, so for if I'm making all the numbers 4, then also 4 operations, and if I'm making all the numbers 6, then also 4 operations. Okay, so both are minimum only, right? So this is the minimum that we can get. Okay, so 4 is the output. Okay, now see this example number 2. So here we have these numbers. Okay, and here if you see, let's suppose if I want to make all the numbers equal to 3. Okay, so here then I have to add 2 times 1. Okay, 1 2 times. Here I have to subtract 2 times. Okay, so 2 operations. Here I have to add 1 time. Okay, so in total 5. Okay, so we can make every element equal to 3 by in 5 operations. All right, so here, okay, this is done. All right, this is going to the minimum. Okay, you can try to make all the numbers maybe 5, then here you have to add 1 4 times. Okay, 4 operations. Here 3 operations. That is not best, right? So you can try different case scenarios, right? So this is done, and now see this example number 3. So here it's interesting, we are getting -1. Okay, so it is saying that it is impossible to make every element equal. Okay, x is equal to 2. So here see, we can either subtract 2 or we can add 2, but here this is odd number, this is even number, this is odd number. Okay, this is even number. So in this even, if I add 2 I will get 6. Here if I add 2 I will get 5. I will never get any even number. Okay, if I subtract 2 from it I will get 1. Okay, I will not get even number. Okay, so that is why in this case it is not possible. So how you are going to check? So in order to check, you can do one thing na? You can iterate over all the elements in your grid one by one and just calculate the remainder, okay, of all these. Okay, with x. Okay, just divide the numbers with x. So here 1 modulus with 1. Okay, this is my x value, so you will get 0. Same way 5 modulus with 1, you will get 0. Since same way 2 modulus with 1, you will get 0. Same way 3 modulus 1, you will get 0. Okay, so remainder is same for all the numbers. That simply means that we can make all the numbers equal. Same way here, if you do modulus of all the numbers with x value, okay, you will get the remainder 0 always. Okay, all right. And here if you do the same thing, if you take 1 modulus with the 2, you will get remainder 1. Here 2 modulus with 2, remainder 0. Definitely it's not possible. Okay, so we need to make sure that the remainder of all the numbers, okay, all the elements in my grid, when I divide them with x, I will get the same remainder. If I'm not getting the same remainder, then it is not possible. Okay, then in that case simply return -1. All right. Okay, this is one way. All right, now there's one more thing now. Here I can do one more thing. I can create one more array, okay, a 1D array, and in 1D array I will just add all the elements like 2, 4, 6, 8, and I will do that in sorted way. Okay, so see, all the elements are in increasing order. Okay, same way here, 1, 2, 3, 5. Okay, a single 1D array is there. Okay, or you can use array list as well. Okay, so same way I will do here, here as well. Okay, but here in this case it's not possible, right? You will check the remainder as well, right? So remainder is not equal to remainder is not same for all the elements, then simply return -1. Okay, now see here, once I do this, okay, I will do one thing here. I will get the median of this. Okay, so here, how you are going to get the median? So this nums array, okay, let's suppose this is my nums array, and here total length is 4, so 4 divided by 2. Okay, I will just divide it in half, and I will get what is the element at my 2 index. Okay, so here 2. Okay, so this is 0 index, this is 1 index, 2 index. At 2 index we have 6. Okay, let's say 6 we have. Okay, at 2 index. So now I will try to make all the numbers equal to 6. Okay, so what I am going to do, so 6 is the median I will take. Okay, so here I will do 6. Okay, 6 is the number that I want to form, minus this current element, 6 minus 2. Okay, and here 6 minus 2 and divided by 2. Okay, so you will get 4. This 2 is nothing but x. Okay, this 2 is nothing but the element. Okay, this 6 is a new number that I want to form. Okay, so 6 minus 2 divided by 2, you will get 2. Okay, so that simply means 2 operations you are doing. Okay, so that's very simple, na? So here same way, here the element that you want to make is 6, and the current element is 4. 6 minus 4, and here you have to divide it with x, so you will get what, 2 divided by 2, that is 1. That is nothing but one operation. Okay, so since you are just adding 1 2 now, so that is why you are going to get operations like this. Okay, so number that you want to form, okay, subtract the element and divide it with 2. That's it. Okay, so this is going to give you the number of 2's, yeah, number of x you are adding or subtracting this. But all right, so same way here 8, if you do, so 8 minus 6 is the number now, so 6 minus 8 you will do and divide it with 2. Okay, and do one thing now, here take the absolute. Okay, math dot absolute, so -2 will become 2 only, so one operation. Okay, because we need positive value now, so one operation you are doing. That's it. Okay, and your question will be solved, right? Same way here, 1 2 3 5. So here take the median, so you want to make all the numbers equal to 3. Okay, so here 3 minus 1, 3 minus 1 divided by x value is 1. Okay, so 2 times you are adding 1. Okay, same way you will get the result. Okay, so it's very simple. Now let's move to the coding part. All right, so let me just zoom this screen. Okay, so here code is going to be very simple. Okay, so first we have to create a list. You can create a list, right? Create a list to store all the numbers from the grid. Okay, so here list, which is consisting of integers. Okay, and here let's say name it as nums array is equal to new array list. All right, okay, done. Then take result. Okay, initial value result. Okay, initialize it with 0, and then we have to flatten the grid into nums array. Okay, so just iterate over all the rows and columns. Okay, so I is equal to 0, I is less than grid. Okay, you can say grid dot length, and here I plus plus, and here for int j is equal to 0, j is less than grid, take first row and calculate the length of the first row, so it will give you the number of columns that you have. Okay, So here j plus plus, and now you have to just flatten. So here you have to do nums array dot add, and here what you are adding grid, and here you have to write I j. That's it. Okay, this is done. Now we have to sort this list. Okay, so simple. You can use collections dot sort, right? Collections dot sort, and in this you have to just pass your nums array. Okay, so it is just going to sort this list. Okay, then just calculate the size of this list. So you can create one variable int length, let's say. Okay, so here you can write nums array dot size. So this is going to give you the length. Now after that we have to store the median element as the first common value, right? So you can say int final common number. Okay, and how you are going to get that number? So this, since we have list now, so here nums array dot get element at which index. So you can get the index as the length of my nums array, nums list, array list, divided with 2. Okay, so you will get the median array. Okay, median index done. So you're going to get the final common number. Now you have to iterate through each number in the nums array. Okay, so for that purpose you have to run one for each loop. Okay, int number in the nums array. All right, and here inside this, first also check now if the remainder when divided by x is different. Okay, then we have to return -1. Okay, so here one base condition you can write, if the number that I'm taking right now, if I am dividing this with x, okay, and I am checking the modulus, okay, of this number, and if the modulus of this number is not matching with the number that I want to form. Okay, so that simply means I'm comparing the remainder, right? So final common number and here modulus with x. Okay, so if they are not matching, then in that case you have to simply return -1. Okay, right, return -1. And if they are matching, then just calculate the number of operations, right? We have to add the number of operations required to make the current number equal to the final common number. So for that purpose you have to write result, and here plus equal to, and here you have to take the absolute value, right? We don't want negative value. So math dot absolute, and here you can write a final common number. Okay, and you have to subtract number from it, and then you have to do the modulus with divide. You have to divide it with the x. Okay, so this is going to give you the number of operations, and then after that you have to just return result. All right, so now this is done. Okay, so that's it, only 21 lines of code. So here if you see the time complexity for this problem, so for this part you can say of m into n. Okay, of m into n. M is nothing but number of rows, and n is nothing but number of columns, let's say. Okay, so this is done, and then you are sorting. So here for sorting process, what you are sorting, you are sorting the nums array of length mn. Okay, and this is going to take log of mn time complexity. Okay, log of mn. Okay, so for sorting we know the time complexity is nothing but mn into log mn. Okay, so mn is nothing but the length of the our nums array. Okay, so overall time complexity here you can see that is going to be of mn into log mn. Okay, dominated by this particular step. Okay, now let's run the code and see if there any code issue. We'll try to fix that. So yes, there are some issues. So here we haven't initialized I value, so let's initialize that. Int I is equal to 0. Okay, any other thing? I think that's it. All right, now let's run it. So see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So, and the time complexity is nothing but mn into log mn. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll meet you guys in the next video. Thank you. Bye bye.